Hello, good morning, everyone, and welcome to today's webinar From Cradle to Recycle, exploring the new battery regulation. We're delighted that you can join us for today's insightful session focused on the transformative EU battery regulation. Today's webinar addresses critical areas impacting all battery chemistries and formats, exploring everything from market access requirements and safety standards to sustainable life cycle management and the new digital battery passports. Joining us today, we have two leading experts from RISE, Sweden's esteemed research institute, Ingvar Karlson, senior engineer specializing in safety and transport, who brings extensive experience in battery safety, transport standards, and life cycle management. Cecilia Wästerlid is also joining us, who's project manager for environment and sustainable chemistry, whose expertise lies in chemical compliance, sustainability assessments, and material circularity in battery production. Our speakers will guide you through the structure and implications of the battery regulation, shedding light into vital topics such as battery testing methods, sustainable lifecycle management, and regulatory compliance strategies across the battery value chain. We encourage you to actively participate by submitting your questions throughout the session, and you can do that with the Q&A tab that you'll find along the bottom of the menu at the bottom, within the menu at the bottom of your screen. So there's a Q&A tab down there for you, and our experts will address these questions during the interactive Q&A at the conclusion of the presentation. So thank you once again for joining us, and without further delay, I'm pleased to hand you over to Ingvar Karlson and Cecilia Wästerlid to begin today's webinar.
Yeah. Thank you, Ashley. First of all, I want to say thank you for the opportunity of being here presenting the EU battery regulation. Since we only have a short while for this session, we will just have an overview of the regulation, and we will not cover every aspect of the battery regulation. My name is Ingvar Karlsson, and I work at the RISE Research Institute of Sweden. And I also have my colleague with me, Cecilia Wästerlid, and she will introduce herself very soon. So if we start with me, I am a senior engineer at the RISE, and I work at the Electrification and Reliability Department. I deal with a lot of battery projects, like battery testing and also battery testing. And we perform a lot of different tests on batteries at RISE, like performance tests, aging tests, and also safety critical tests like short circuit tests, fire tests, and things like that. I'm also involved in battery courses. So I have battery courses, how to handle batteries in a safe manner. And I'm also involved in battery fire safety courses here at RISE. So that's a little introduction of me. And over to you, Cecilia.
Yeah, and my name is Cecilia Wästerlid, and I'm based in Stockholm. I work with circularity of metals, and I do that mainly on a value chain level, policy level. And as you understand, metals and batteries, that's a combination that's of extreme interest to me. So that's how I get into battery. And I will talk mainly on the recycling part of the battery regulation. So back to you, Ingvar.
Thank you. So if we look at the Research Institute of Sweden, it is an institute and it is totally owned by the government, and we have around 3,300 employees all over in Sweden. We take part of a lot of research projects, and we also have a lot of test beds where we can test different products, both for fulfillment of standards and also for development testing. We are a polytechnical institute, and we work in many different areas, you can say. And of course, batteries are one of those areas. So if we look at the batteries at RISE, when it comes to batteries, we have a lot of research projects, and we have research projects in fire safety. We have in battery materials, manufacturing and processes, applications and function, recycling and circularity. Also, as I said before, we have training courses in battery fire safety. We also have introduction to battery safety and functional safety for BMS and measurements in battery systems. We are a research and test institute, and of course we have test facilities, so we are testing a lot of products, and of course we are also testing batteries for safety issues and also for performance tests and so on. We have 3 new test sites for testing batteries, 2 sites for development and performance testing, and we have 1 test site for safety critical testing of batteries. Why should you test batteries then? Of course, when we store a lot of energy, it is also a risk involved in that, and therefore it is important to test the batteries we are setting on the market and show that they are safe to use. We also want a long life of our products, and therefore it is of interest to test the durability and performance of our batteries. Those 2 parameters will also be a requirement in the battery regulation that we will come into here. If we look at, as I said before, we have built 3 new test sites at RISE in Sweden, and we have built 2 test sites for testing drivelines and testing performance and aging properties of batteries. And we also have a battery safety lab that we have is situated in Borås, close to Gothenburg. And here we can test batteries indoor, and we can test batteries full-scale electric vehicles and battery packs up to around 200 kilowatt hours. And we can expose them to fire test, thermal propagation test, electrical test, vibrations, and also temperature test. Here we have a smoke gas cleaning system, and we have a cleaning system for extinguishing water, and this makes it possible to test a green technology in a green way. We call it the Battery Safety Laboratory, and this is a safe laboratory for battery safety testing, you can say. So we have 500 millimeters concrete walls in the test labs. We have lids in the ceilings of the labs. So if we have a pressure relief, like an explosion and things like that, so we can take care of those incidents also. So here we can perform safety tests in a safe and green way. So that was a little introduction, and now we can go over to the battery regulation a little bit more. And as an introduction, I would like to say that many applications today require batteries. We have them in a lot of applications, like electrical vehicles. We have them in lawn mowers. We have them in battery equipment, handheld battery equipment, and we also have them in light means of transport applications. And also now we are storing a lot of energy from wind and the sun, so we can use this energy later on when we need the energy. So battery energy storage systems are also a big area right now. And of course, many applications require batteries, and also those products must and shall comply with applicable EU requirements. And just if we look at at many products today, they are quite complex, and therefore you have many EU requirements that you must comply with. So if we look at the BESS system, for example, here you have a lot of components, like you have radio Wi-Fi modules, you have power conversion and inverters, you have battery packs to store the energy in the battery packs, and you also have a management system to controlling all the parameters in the battery packs. So you have some sort of BMS function system in your application, and also you have other systems like cooling systems, heating systems, ventilation systems, and things like that. And of course, it is your responsibility, if you are setting your product on the market, that to make sure that you fulfill all applicable EU requirements. So here you can see some of the examples of EU requirements, EU regulations and directives, like the EMC directive is one example. You have the radio equipment directive, RED. You can also have the low voltage directive that must be applicable, and of course the battery regulation, and in some cases also the machinery directive, the pressure equipment, and other requirements will be applicable for your application. When you put your product on the market, the European market, you must have a CE mark on your product, and you must issue an EU declaration of conformity, and that is in some cases a self-declaration, but in some cases you must have a notified body involved in this CE marking also. And this EU Declaration of Conformity is a mandatory document that you as a manufacturer or your authorized representative need to sign to declare that your products comply with the EU requirements. And it is utterly important to know that by signing this EU Declaration of Conformity, you take full responsibility for your product's compliance with the applicable EU laws. If we look at the EU battery regulation, you can download that for free on internet. And here are the links for the English version and for the Swedish version. You have the EU battery regulation in many languages, but here is the English version and the Swedish version. If we look at the battery regulation, the new battery regulation entered into force in August 2023 and applies from February 2024. We already have a battery directive, and that battery directive will continue to apply until 18th August 2025, and then it will be replaced by the new battery regulation. It is quite a complex regulation, the battery regulation, and we have many implementation steps. And the first implementation step was in February 2024, and then it will be applicable and implemented in many steps until 2036, I think. Is that right, Cecilia?
Yeah, at least that's one of the dates that we see in the regulation today.
Yes, yes. If we look at the regulation, we have requirements for market access in Europe. So we have a CE marking in the regulation. And it is also important to know that this applies to all battery chemistries and battery formats. So it is not only lithium-ion battery, this is all chemistries and battery formats that is into this battery regulation. as I said before, this is quite a complex regulation, and there are so many words in this regulation. I think that it is 117 pages with just a lot of text. And it can be quite hard to get into reading this regulation. But a good advice is to start with Article 3. There you have 15 definitions of batteries, and here you can identify what category your battery will be in when you read this regulation. So here you can see you have definitions for portable batteries, portable battery of general use, and you also have light means of transport batteries, EV batteries, stationary battery, energy storage system, and so on and so on. So this is a good starting point when you read the regulation. If you look into the regulation divides batteries in these categories, 5 different categories, and that is portable batteries. You have SLI batteries, starting, lighting, and ignition batteries. You have LMT batteries, light means of transport. You have electrical vehicle batteries, and you have industrial batteries. And the example that I showed before about BESS systems, stationary battery energy storage systems, they are included in the category industrial batteries in this regulation. And as I said before, we have those 5 categories, and you can look into the Article 3, what those categories stands for. So this is a good information. We also have 3 articles about CE marking and the declaration of conformity, and they describe how to CE mark the products. And it is good to know that a CE marking on a battery will indicate the conformity of that battery with applicable parts of the new EU battery regulation. So depending on which category you are in the battery regulation, you have different articles to fulfill. It is also telling in the regulation that where a battery is subject to more than one Union Act requiring an EU declaration of conformity, a single EU declaration of conformity shall be drawn up in respect of all such Union Acts. So if your product falls under different regulations and directives, you should have a single EU declaration of conformity for your products. For some articles, self-declaration can be used, and for some articles, you need a notified body, and we will come to that a little bit later. For CE marking, an EU declaration of conformity shall state that the compliance with the requirements laid down in Articles 6 to 10 and Article 12, 13, and 14 has been demonstrated. So if we go over to the next picture, here you can see which articles are involved in the CE marking and declaration of conformity for the products. So here you have the columns with the 5 different categories. Here you have the portable batteries, the SLI batteries, light means of transport, electrical vehicle batteries, and the industrial batteries. And also you have those articles in the lines here. And you can also see when we are implementing the different articles for the different categories. Here we also have the blue ones, articles here. That is where self-declaration can be used. And Article 7 and 8, here you must have a third party, a notified body involved for fulfillment of those articles. As I said before, those different articles are applicable for different categories. And if we look at Article 9 and 10, those are for performance and durability requirements for different categories of batteries. And Article 9 are for batteries, portable battery of general use. And you also have coupled to the Article 9, you have Annex 3 in the regulation, and there you have the parameters or electrochemical performance and durability parameters for portable batteries of general use. And there are one part A for parameters for non-rechargeable batteries and part B parameters for rechargeable batteries. It is the same for Article 10, but that is for rechargeable industrial batteries, LNT batteries, and electrical vehicle batteries. And that is only valid for when the industrial batteries are more than 2 kilowatt hours, the energy content in them. And here you also have an Annex 4 that is presenting the performance and durability requirements for LNT batteries, industrial batteries with a capacity greater than 2 kilowatt hours, and electrical vehicle batteries. Also, we have safety aspects in the battery regulation, and that is only for stationary battery energy storage systems. And here it is a little bit tricky because we don't have any harmonized standards for testing those parameters. So the only thing that they are stating in the regulation is what kind of safety parameters you must look into and fulfill the requirements for. But you must make a best guess which standards you must test against. So I have made a best guess for suitable standards for lithium ion, and then this is for lithium ion batteries. And the good advice is to start with UN 38.3, which is UNEC's requirements for transportation of dangerous goods. So there you have some of the safety aspects in that standard. Also, you have the safety standard IEC 62619, and that is a safety standard for industrial batteries. And the reason why I'm picking that is that this standard is mentioned as a reference in the battery regulation. We also have a good standard, and that is IEC 63056, and that is a standard that is an understandard, you can say, from IEC 62619. The 62619 is for industrial batteries, and IEC 63056 is additional test procedures for stationary battery energy storage systems. If we look at 10 and 11 here, fire test and emission of gases, I have not found any suitable standards in IEC standards or EN standards. So here I refer to the Underwriters Laboratory 1973 and UL 9540A. And of course, there are work in progress to develop harmonized standards. So this is the best guess for now. And when we are approaching those harmonized standards, we can go to them instead. Yeah. That was my bit. So over to Cecilia.
I will take over. I was just, we were asked to remind you, listening to us, that you do have the Q&A tab where you can enter your questions, and please do. We will have a check in the end. So let me get started, Ingvar. So I will just start. So now I will talk a little bit more with the recycling perspective. And first of all, we do talk about a lot of the regulations here, but it's good to understand that some of these articles you need a notified body to check up on you. And it's regarding the carbon footprint, it's regarding recycled content, and also verification of a battery due diligence and your policy there. So that's good for you just to have in mind when I continue. And if you take the next picture, Ingvar.
Yeah.
So getting into recycling, one of the main differences coming into the regulation was that it really added requirements on recycling. So there are requirements on recycled content going into new batteries. There is requirement of collection targets, how the batteries will be treated, and also some regarding recycling efficiency. And as you can see here, I've just noted down which articles, but also, again, as Ingvar was telling in the beginning, there are so many different kinds of batteries, and not all regulations are for all types. So that's also worth noting that, I mean, you go in and check for your battery type, and then there are different regulations. And we can take the next picture, Ingvar. So regarding recycled content, you see these two dates, and there you see the 2036 date that we were talking about in the beginning. Here are some requirements on how much recycled material should go back into new batteries. And as you see there, the two dates, 5 years in between, and we actually start at one point, and then it's a little bit tougher 5 years later. When the regulation was written, lithium, for example, was not recycled at all within the EU, but here it's quite large extent it should be recycled and back into new products. And as you see, it's for each battery model per year and per manufacturing plant. And this is one of the articles that should be checked by a notified body. We can take the next picture. And another newcomer is that in Article 70, it actually says that collected waste batteries shall not be disposed, and they should not be subject of an energy recovery operation, which is interesting, as today a lot of the plastics in Europe is actually used for energy recovery. It's incinerated. It should not happen. And also a main part of batteries today, lithium-ion batteries, is graphite. It should not be incinerated for energy recovery in the future. Or actually from today, I think that's valid from already. And also all waste battery that is coming into a facility should either be reused or prepared for repurpose, or they should be recycled. So they will not be deposited or landfilled anymore. We can take the next picture and the next. So here is some regarding material recycling. And as you see, this is a date this year, 31st of December. And here we have some percentages on how much should be recycled. And of course, you would ask percentage of what? And that type of information is to come, how to calculate this. And then you can take another click there. And here is also how much recovery of certain materials that should be done. Quite high requirements, I would say. But as you see, they are defined for a few of the elements that's commonly used. And I would say in a battery today, maybe you have 15 or 20 different elements. So the targets are set on certain, the more important ones. And as you see, first you have one day and 5 years later, it's improved. So that's how many parts of the regulation is done. First, I think in many of them is also just tell how it is today. And then there's certain targets. And then there's another, a few years later, it's a little bit tougher. We can take the next picture. Then there's also other articles that are important if you think recyclability. And one of them is this Article 11, where it should be possible for certain types of batteries to remove them and replace them. And there's a few others that is disregarding that you need to have an understanding and actually be responsible that the batteries are taken care of at their end. And it does say that you need to be either responsible yourself or you're become a member of a producer's responsibility organization. And then you have the digital battery passport, which is a product passport. And I will get into a little bit more information regarding that. We can take the next picture. So the battery passport, this article, valid from 2027, you start up with a QR code. So all batteries should be having a QR code. And then when I say all batteries, it's of course not all the batteries, but it's for LNT batteries, industrial batteries with a capacity greater than 2 kilowatt hours. And I think that passed maybe very quickly when we talked about the different types of batteries, but actually this is not only the type of battery, but it's also its capacity that's important. And it's all in Article 77, and we can take the next picture. I will go through that a little bit. So I will go through the life of the passport because it's kind of interesting to understand what can happen with the battery and how the passport will be adapted. So you can click once, Ingvar. So the passport sort of is born when the battery is placed on the market or put into service. It is the economic operator placing the battery on the market that should ensure that the information in the passport is accurate, complete, and up to date. And then we're talking quite a bit regarding, okay, you do have a battery, maybe that's repurposed or used for something different. It started up maybe as a vehicle battery, and then you would like to have it as your backup battery for your solar panels or something else. Then it's stated in the regulation that what you do is that you need to link a new battery passport to the old one. So that should be traceable backwards, what it started up with and what it will continue as. And then you can click once. And then when it becomes waste, that should change in the battery passport. This is now waste. And then if you click one more time, then in the end, when there is no battery anymore because it's been recycled, that's when the battery passport actually ceases to exist. And all this is defined in the regulation. And if we look a little bit on the passport itself, what goes into this passport, you can continue, Ingvar. So there is this annex where it keeps all this information. Again, it's for the LMT battery, electric vehicle battery, and industrial batteries with capacities greater than 2 kilowatt hours. And 2 kilowatt hours, I'm not sure that's why it's been selected, but if you have an electrical vehicle, it is what takes you about 10 kilometers today. More regarding the battery, it's valid from 18th February 27. It is for each battery. It's digital information, and this information has 4 access levels. So not all will access all information. And these are the levels. You have the general public. You have the people who would dismantle your car or repair your car. They need to understand how to do it, and they should be able to access that information. It's for notified bodies, and then there is also some legitimate interest for individual battery information if you would look into your particular battery. And you can click once more, Ingvar. And again, there should be a QR code. You can click back. QR code on each battery, and that's where you would access this information. So you will go to a place where this information is available. And that system, it does say in the regulation that the EU provide the system. It doesn't say they are they're not running it, maybe. I can't remember exactly how it's worded, but there will be a system, and it will have these 4 parts, as I was talking about. General public, number 2 there is really for the repair companies, and the other 2, which are smaller interest in it. And now you think this is an easy piece, and you can just click once on how much information that goes in each. I'm not going to go through this. I'm just telling that there's a lot of information there. And all of these will be defined into detail, exactly what goes in the passport, what format it will have, and how do you interpret exactly what it actually says if you are a reader of that information. So please go in here and really check on this. And there will be some implementation acts, and that will define this exactly how it should be done. So I think that was my last slide. I said, go back to you.
Yeah. So as I said before, this is we don't have so much time to present this. So this is an overview of quite a complex battery regulation that we are dealing with. So as a summary, I would say that this battery regulation is a complex regulation, and there are different requirements and implementation times depending on battery type, on the battery category you are in. So it is utterly important for you who is putting your product on the market to identify which articles are valid for your product. We have also recognized that it can be hard to identify and understand what additional regulations and directives you must fulfill before setting a product on the European market. If you look at the BESS systems, for example, there you must apply to many different regulations and directives, and that can be hard to understand. And here we can help you with this with requirements investigations. We can also provide you with training about the battery regulation and also battery safety and things like that. We can also perform safety and performance battery testing at our sites here in Sweden at RISE. And we can also do a lot of other testing for according to harmonized standards to other directives and regulations at RISE. As I said, this is just a short overview, and there are many interesting topics about battery safety. And I would like you to inform that we have a battery safety conference the 19th of March 2025 in the beautiful city of Gothenburg. And you have the QR code here, so you can go in and have more information about that. So I wish you welcome to an inspiring conference focused on battery safety, and please read more about it on our website. You can also have a lot of more information on our website at ri.se. And with that, I say thank you for listening. Here you have another QR code where you can go into LinkedIn and have more information about batteries at RISE. And you also have our email addresses. So please feel free to contact us if you have questions about battery safety and the battery regulation. So with that, we can move over to Ashley.
Thank you ever so much, Ingvar and Cecilia. Let's have a look at some of these questions, and I think we've got enough time to get through some of them. So, first question that we've had from the audience today is, can you elaborate on the technical standards underpinning the digital battery passport, particularly regarding interoperability across different battery chemistries and formats?
Can you repeat that? I didn't really understand.
Of course I can. So it's, can you elaborate on the technical standards underpinning the digital battery passport, in particular regarding the interoperability across different battery chemistries and formats?
Can you start there, Cecilia? You think?
Yes. I will just say it's a very, very good question, because as I said, regarding all the different information pieces that should go into that passport, there is of course a standard. There is a definition on exact format that should go into the passport itself. What information should be there? How long can you put in what unit should it be? And I would just say there is ongoing work on all the details.
Yeah.
So I would say that I'm not able to go into that detail, but there will be information available. And that I think in the regulation, they refer to, I can't remember, it's like 30 plus implementation acts for certain requirements. And they will point to, there will be expert groups that will point to standards if they're available, or they will prepare standards, or just tell. This was a very complex question regarding different chemistry and how should it be measured and what exactly should go into the battery passport. But even as I think more simple requirement as what percentage is actually recycled, it also raises quite a few questions on based on what. Is it new sales? Is it old sales? Is it recovered material? There are so many questions. So I would just say, I don't think it's defined yet. It will be defined.
Yeah. And I also think that in the regulation, they have pointed out that there are loss of standards and things like that. So there will be a lot of guidance through the implementation here in the regulation. Yeah.
Thank you ever so much. What are the most technically challenging aspects battery manufacturers face in demonstrating compliance with the new EU safety requirements? especially concerning thermal runaway and propagation testing? Excuse me.
I think there are different aspects in that, because if we look at the safety parameters, that is only for stationary battery energy systems. And the reason for that is that I think the reason for that is there are no other regulations that is taking the safety aspects in account. So now we are focusing on in the battery regulation for the best systems. And of course, it is a little bit tricky when you don't have the harmonized standards. And that is also pointed out in the regulation, that we are lack of harmonized standards for safety testing, for performance testing, and things like that. And we must develop harmonized standards for this regulation. That is utterly important. And I know right now, like performance standards like IEC 62620 is under work in the technical committees and things like that. And hopefully we will have harmonized standards quite soon. So yeah, it is. We have a lack of battery testing standards right now, but hopefully it will be better and better. And as I said before, now we must have a best guess how to test those safety parameters, because it is really clear in the regulation that you must fulfill those safety parameters, but we are not pointing at any standards. So now we must make a best guess from the application and what kind of standards you have to test for. So it is a challenge. I totally agree with that.
You also, just regarding the safety and understanding the state of health of your battery. I mean, if you have a vehicle battery that could be built up of 5,000 to 8,000 cells, and really you need to understand the state of health of each one, and if it's near to a short circuit or not, because that's where your thermal runaway will start, in the short circuit. And it's quite difficult actually to measure which of your cells is near to that. So I would say that's very challenging.
Yeah.
Standard or not, I would just say how they built up, and understanding, I mean, the state of health of all your cells in your battery.
Yeah. And also, of course, if we look at the safety parameters and things like that, and safety standards, we are not really ready for this, because the progress have been so fast with the energy content in the batteries and things like that. So now we have so huge amount of energy content in the battery, the best systems and things like that. So we must have a development in the standards. Absolutely.
Thank you. And I think you've actually answered the next question all in one there. So we'll move on to, how will the new battery regulations technically affect transport safety procedures, especially for the end of life and second life battery logistics? So how will the battery regulation technically affect transport safety procedures, especially for the end of life and second life battery logistics?
Of course, that is also a very good question, because if we look at the transportation tests now, like UN 38.3 for lithium-ion batteries, that is based on new produced batteries. And of course, it is hard to do those safety tests on used batteries. That is, you don't have that much batteries to test on and things like that. So of course that is a challenge, but I don't really have the answer for that. It is a good pinpointed question. So
one thing that will be good is if you do have the passport, the battery passport, there will be information on how you should handle the battery in the workshop. But the thing is also the first batteries that come in are from crashed cars. And you might have a crashed battery, not all of it, but part of it. And then you do have this problem. It might be short circuit. So I would say it already affects, I mean, not by the battery regulation, but it's unclear out there, how should the workshops really treat the batteries?
Yeah.
How dangerous are they to actually, and some, you know, just put them away from the workshop and they haven't started to transport them yet. That is an issue, definitely.
Appreciate that, Cecilia. Thank you. What advancements or modifications in current battery testing protocols do you anticipate to fully comply with the new regulations, life cycle and safety requirements? So what advancements or modifications in the current battery testing protocols do you anticipate as necessary to fully comply with the new regulations, life cycle and safety requirements?
I think the main problem is how to identify which standards you should test against. And of course, we must have a standardization committees that are dealing with these issues, because as I said before, the batteries are getting bigger and bigger, and the standards are not really made for those big batteries and this huge amount of energy content in the batteries. So I think the main issue here is how we must have a progress in the standardization, so we can test in the right way to the right size of the batteries. That is the main problem here. I think so. Yeah.
Thank you ever so much, Ingvar. Could you discuss the technical criteria used to determine substance restrictions within new battery regulation and how these criteria might evolve as battery chemistries advance?
Can you answer that, Cecilia?
Yeah, I mean, you do have requirements today on cadmium and a few of these metals that we are actually removing from society, and that's for the smaller batteries. I do know that some of the recycling facilities that maybe focus on EV batteries, they would just say, we're not taking these smaller cadmium cells. We don't want cadmium in our plant. You know, that goes somewhere else. But then, of course, there might be new regulation, though it's not part of the battery regulation, and that's regarding fluorinated hydrocarbons. You know, these stable chemicals that will be around forever. And you do have fluorides in your lithium-ion batteries as part of the solutions. There might be, and the levels allowed today is already very, 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 very small. So that's not in there, but it might come. So, but for sure, what I would say is that the more we learn regarding different elements and the chemicals and how they affect the nature and the wildlife, we will get harder restrictions. So it just goes in that direction, actually. Then again, if you have a look on lead, we don't want lead in society, but it's also quite easy to recycle. So I think in Sweden, for example, lead batteries are recycled to above 99%. So we have these collection systems and, you know, good plant for recycling it. So that works fine. So it's not a closed system, but it's nearly closed system. So that's also one way to how you can deal with a problem, that you keep it sort of in a contained system. So yeah, I'm not sure I answered, but at least give you some more background and more how complex it is. Yeah.
Well, I thought it was a great answer, so thank you. Which specific chemical processes or technologies currently show the greatest potential for effectively recovering critical raw materials from diverse battery chemistries under these new EU regulations? So let me ask you again, which specific chemical processes or technologies currently show the greatest potential for efficiently recovering critical raw materials from diverse battery chemistries under the new EU regulation?
I don't really have the answer for that. I think that is more for our research areas at RISE to answer that question.
But I think, I mean, the processes are out there today for like copper, there's some silver, from cobalt, nickel. I think we're quite good. We will, that will work out. Lead, I would say lead batteries, we're quite good. Lead used in other products, maybe not so good, but that's regarding the collection. It's not because we don't know how to do it. What will be difficult is when, for example, lithium is not recovered today. It is starting to get into the process because of the requirement. I mean, I think the battery regulation is pushing in the right direction. The problem here is that there are some metals that actually have a second value. We don't really care where they come from. I mean, who is asking in the gold shop, is this reused gold or is this the first-hand gold? No one is asking. So we will come to that for all the metals, but we're not there yet because it's a complex procedure. But for the metals that has a value, they're already recycled and recovered quite efficiently. Actually, the problem is the rest of them. So, and we will just make progress when there is these requirements, I would say, and that goes for all society. It's not only for batteries. If you check on your mobile phone, I guess everyone listening to this have a mobile phone very, very near to you. You have around 40 to 60 metals in your phone. It's kind of cool, but we don't recover it or we don't recycle it. So, but we will in 10 years' time. We will.
Thank you. What are the recommended methodologies or analytical approaches to evaluating life cycle environmental impacts of batteries to meet regulatory requirements?
It is one of these implementation acts that require life cycle assessment. And that's, I would say, that's a well-known method. And in the implementation act, that will be how do you do it for the battery regulation. I know there was a proposal out, I think this summer. I'm not sure if that's been now confirmed and published, but at least there is some proposal out there.
Thank you. From a chemical sustainability perspective, what are the technical challenges in standardizing procedures for validating materials recovered from waste batteries as suitable for reuse in new battery production?
The question is quality. So if you're using a material, you usually want it of a certain purity or a certain mixture. So if you've used something in your battery and that's a perfect mix for your new application, just move it. The problem is when you get two mixed products. If you, for example, you have a variety of chemistries, it's a mixture, maybe it's not what you want. Then you need to purify it or you need to prepare it. And that's when it becomes difficult because you need to check on it. And depending on how diverse your second-hand material is coming from or how diverse it is, it becomes more difficult. So I would say it's like normal quality procedures, and the techniques are out there. It's just that it might become overwhelming if you have so many different types of mixtures, alloys, that you are to get into something new. But this is what recyclers are living through every day.
Mm.
So, but that will also be improved. When we look back 10 years from now, I think we sorted many of these questions because we will recycle more.
Thank you ever so much. We've got so many questions. I will try and get through a few more and just overrun slightly. But for the rest of the questions, I will make sure that I send them across to Ingvar and Cecilia, and they can, of course, get back to you directly. Right. So how can detailed chemical composition data embedded in the digital battery passports technically support better end-of-life handling and material circularity? Are there current technical limitations to this approach?
I mean, in the perfect world, you would know exactly what your battery contains and you would treat it exactly like that. But there is an issue regarding to what level can you specify the content. And that goes both because it might be so many rows of information, but it also may mean that you are actually disclosing, I mean, the key elements of your competitiveness as a battery supplier. So maybe you don't really want to inform the world that this is the exact chemistry that we're using. So it might be proprietary. So that's an issue. But it's also that, as I said, in the regulation today, they have, I think it's 5 or 6 elements that is that these are the requirements for they should be recycled and reused. But actually in a battery, it's maybe 30 different elements. And we do have these figures for every one of them. So that's also a problem when you come there. So I would say, of course, if you could say, okay, this battery contains this and this important element, and that was easily found, that could be a way of sorting your different batteries. And by using the QR code, maybe that could just be done digitally, and that would speed up the whole process.
Thank you so much. In the recycling efficiency, does that mean that X% of a battery's total weight should be recycled, or does it mean something different?
I mean, in here, you should really go back and really read the exact wording in the regulation, but it will also be supported by these implementation acts. Like, what do we actually mean? Percentage of what? And not all these implementation acts are actually in place yet. So, an implementation act, I'm also meaning delegated acts, because sometimes you know what to do, but it's not implemented. Sometimes it's a delegated act to actually specify. So I would say, when it comes to this, how should this calculation be done compared with what percentage of what? How will it actually be done? I would say it's not set yet. It might be in part. And as I said before, there's like 30 plus of these delegated act and implementation acts that are supporting the battery regulation.
Thank you. I've been taking notes during your presentation. Oh, let me get rid of this one as well. So can you discuss the technical intricacies involved in obtaining CE marking under the new battery regulation, especially regarding the documentation of life cycle aspects and the demonstration of compliance across the battery's entire life cycle?
I cannot answer that immediately now. I think we have to point that out to us, and we can make a better answer by email or something like that.
Thank you, Ingvar. So I shall send that question across to you after. From an engineering standpoint, what specific design changes or technical innovations might battery manufacturers need to adopt to comply fully with the life cycle and safety provisions? So from an engineering standpoint, what specific design changes or technical innovations might battery manufacturers need to adopt to comply fully with the life cycle and safety provisions of the new battery regulations?
Of course, that also depends on what application you have in this battery regulation. So, of course, you have the Article 11 for portable batteries, the replacement of the batteries, and that is one kind of challenge. How do you remove the batteries and replace the batteries? And of course, if we look at the safety issues and the performance articles, it is quite hard to say what you have to change, because you must also look into the applications in what category you are in. And of course, the regulation is quite clear about what you have to do, because they say that if you have different applications of your battery or your battery cells, you should always go for the hardest requirement in the categories you are dealing with. So as we have said before, it is quite hard to answer that in general terms. So you must look into your applications all the time.
Thank you. Well, we've got so many questions that have come in.
We are on overtime.
And we've run over time, and I appreciate
I've
kept you on now for over now. So we have questions from Torben, Laura, Kane. I shall pass all of these questions. There's another 28 to get through across to Ingvar and Cecilia, and I'm certain that they will reach back out to everybody, either to answer the questions personally or directly.
You're welcome with the questions. Yeah.
I very much appreciate your time this morning, Ingvar and Cecilia, and thank you very much for a very thorough presentation, for really getting into a whole bunch of very technical questions. Thank you again for RISE and for today's webinar. So I shall say goodbye to everybody for now, and we'll see you all again, and I'll leave Ingvar and Cecilia to say goodbye, and then we'll finish for today. So that's all from me, folks, and I'll see you again very soon.
Yeah. Thank you very much.
Thank you so much. Take care now.
Thank you.
See you all again soon. Bye-bye for now.
Bye.